Welcome to IGCSE Year 10 Physics. In this video, we're going to talk about work done. Under IGCSE syllabus, the student have to know that work done is equal to energy transfer, meaning if there's energy being transferred from one form to another form, there's work being done. The student also have to know how to relate the work done without calculation to the magnitude of forces and the distance that is moving along the direction with the forces. That distance is in the same direction as the forces. And under a standard syllabus, the student has to know how to use the equation work done is equal to force times the distance, and again this distance is along the direction of forces, and work done is equal to change in energy. Okay, just now under the syllabus, we know that work done is equal to energy transfer, meaning let us look at this example. There's one person lifting up box from down here to the up, from the bottom to the top. Okay, when this person lifting the box up, there's energy being transferred, which is from chemical energy to gravitational potential energy, or in short, GPE. Okay, the chemical energy is being stored in the muscle, and that energy that is stored in the muscle is being transferred to GPE due to the height. Okay, so here we know that work done is equal to force times the distance moved by the force in the directions of the forces, meaning the force and the distance should be in the same direction. So from this equation, we can also know that the work done is actually depends on two things. The first factors are the size of the forces, meaning the greater the forces, the more work is done. Second one, the distance moved in the direction of the forces. The further it moves, the longer it moves, there's more work done. As in the picture down here, okay, we can see that there's 1 Newton forces push this box to the right, and the direction that is same with the direction of the forces here is 1 meter. So meaning the direction of the forces and the direction of the distance should be in the same plane. Okay, in short, we can put work done equation in this triangle, so we know that when we want to calculate work, we just close this work is equal to force times distance. And let us look at the unit for work done. Okay, since work done is equal to energy transfer, so work done unit should be equal to energy unit, which is joule. So since force, the unit for force, the SI unit for force is Newton, and the unit for distance, the length, is in meter, so the final answer when we calculate the problems, when we calculate the questions, should be in Newton meter, and that Newton meter should be the same, is equivalent to joule unit. Okay, let us look at first example here. We have by looking at this picture, we have one crane creates a box upwards to the height of 20 meter, and the force that is being putting here is 5 kilonewton, and we have to calculate how much is work done by the force. Okay, first thing first, we know that this is our forces, 5 kilonewton. So 5 kilonewton is equal to 5,000 Newton. When we have small letter k before the unit. Okay, we know that that one is kilo, and kilo means we have to times these numbers in front here by 1000. So we have 5000 Newton force, and the distance that is moved along the way with the force is 20 meter. So we straight away we can calculate the work done. The work done is equal to 5000 times 20 meter is equal to 100,000 joule. So in the question asks us how much energy is transferred. So since the work done is equal to energy being transferred, so the energy transfer is equal to 100,000 joule. And work example 2, just now we have like very straightforward questions. Right now let us see at what if this person tried to push the box along the platform that have some degree from the ground here. Okay, so so let us just figure out what is the information that we have here. Okay, the information that we have here is the force, which is 200 Newton. So a girl can provide a pushing force of only 200 Newton, so the force is 200 Newton. So to move a box weighing 400 Newton onto a platform, she used a plank as a ramp. How much work does she do in raising the box? So we want to calculate the work done that this girl do. So the work done that this girl do is, we take the force is equal to 200, and we take the distance that is along the direction of forces, that is the same with the direction of forces, which is 2.5 meter. We cannot take 0.75 meter here because it is not due to the forces that this girl put on the box. So the work done here is 200 times 2.5 meter is equal to 500 joule. Okay, with that, let us summarize what we have learned today. So we should know that work done is equal to energy transfer, and we should know how to relate without the equation that work done depends on the size of forces or the magnitude of forces. The bigger the forces, the more work is done. The second factor is the distance that move along the way with the forces. So the higher the distance, the higher the work done. With that, I thank you for watching.